So, friends, welcome to this lecture series of geomorphology, and today we will continue with the fluvial process. So, if you remember the last class, we are talking about these channel habits depending upon the grain size, depending on the bed load, depending on the water, slope, so all these factors. So, we have 6 channel habits identified, and those 6 channel habits they change with time depending upon all these variables. Okay. So, last class we are talking about this channelization or artificial straightening of channels. So, we found that artificial straightening, though some advantages are there, some disadvantages also there. So, by artificial straightening we reduce this stream length, so that the navigation time, the fuel, it decreases. But in artificial straightening we reduce the flood risk of this area where we are going for this artificial straightening. However, with some time, with some going 2, 3, 4 years or so, we are increasing the risk of flooding in the downstream, because much water can easily be passed through this artificial straightened channel, and that will be in the downstream, it will create severe floods. Similarly, artificial straightening also it erodes the river bank, and river bank collapse will be there, so that sediment production will be very high, and due to high sediment production again the river bed aggradation occurs and the flood situation comes as it was earlier. And today we are going to discuss about the other types of channels or the other channel habits, like this meandering channel, the braided channels like that, anastomosing channels like that. So, we will start with this meandering channel. What a meandering channel is and how it forms, how it changes, what is the significance of meandering channels in geomorphology, and whether these meandering channel types they produce some types of economic wealth for us, or how it is studied. These meandering channels they are associated with point bars, and point bars, as you know, it is capped by a clay sheet, and at the base we have gravels and we have coarse sands like that. So, as point bar migrates, so we will get a continuous sheet of clay which is capping the sand. So, many times this may be potential sites for petroleum hydrocarbon accumulations, and it is in fluvial environment. So, let us talk about how this meandering channel forms and how they behave with a change in grain size and with change in slope like that. So, a single sinus alluvial channel that carries only suspended load, mind it here, this point to understand is it carries only suspended load and small total load and low velocity is simple example of meandering. So, 3 factors are there, these 3 factors influence this meandering or meanders very well. First is it carries only suspended load. Second thing, that this total load is very small and its low velocity. So, low velocity channel it will be, total suspended load will be, and less total load will be. So, these are the 3 essential conditions for forming a meandering channel. And channel width stays reasonably constant, though this channel changes its position from one place to a lateral migration will be there, but this width of this channel, this distance between 2 banks remain constant. So, its channel width stays reasonably constant between stable banks, but as the curvature increases the neck cutoff can occur. So, we know about this neck cutoff, cute cutoffs like that. So, if you see here in this first case and this is the second case, here this is in example of meandering channel, this is the direction of flow, water flow or the channel flow. Now, you see here earlier the channel was migrating or channel was passing through here, later on it here, and finally it is moving here. And with time, if you see here, with time this channel it moves in this way, this width it is moving this way, and if you see gradually these 2 points they are coming closer and closer. If you see here, they are coming closer and closer, and finally this system, these two system will join together, and finally this will be a channel, it is a single channel will be developed here, and this part remain abandoned. So, the channel migration takes place from here to in these directions. So, this is called neck cutoff. So, neck cutoff, that means a part of this channel is remain cut off, and once it remain cut off. So, during flood time this cut off part it receives much sediment as suspended loads and sites for silt and clay deposition. So, a plume experiment was carried out by Sohm and Khan in 1972 to produce meandering channel in laboratory artificially with some variables. So, changing variables like slope, discharge, sediment load. So, all these parameters were changed or adjusted very minutely and found out there is no meandering channels were developed until unless this system or this experiment was fed with clay particles or without these clay particles there was no meandering channel developed. So, here in this experiment poorly sorted sand was used, that means sand it is starting from very fine to coarse particles, sand particles were used, and they were able to produce channels with alternating bars and pools, so that the thalways meander, but the channel banks remain essentially straight until the stream abruptly develops mid channel bars and becomes braided. So, a truly meandering channel could not be formed until 3% by weight of kaolinite clay was mixed with the water. So, that means I want to say here, this experiment says once we have coarse grain material or coarse grain bed loads or coarse grain loads like sand, it will not or it will never produce a meandering channel. So, the essential criteria to produce a meandering channel is it must have clay size particles within that. So, that this experiment said until unless they used 3% by weight kaolinite within the system, this meandering channel was not formed. So, the what is the mechanism why clay was added and what is the mechanism why clay was responsible for formation of this meandering channel is explained here. The clay coated and stabilized the banks and bars and allows these thalways to deepen and expose the stabilized sandbars on alternating side of this channel. So, once the alternating side of this channels was bars were stabilized, the thalways moved and finally it forms meanders. So, this experiment illustrates well the action of alluvial grain size as a factors in the hydraulic geometry of river. So, either it will be a straight channel, it will be a meandering channel or a braided channel, that depends upon the grain size. So, this experiment says until unless we have clays within the system, clay within the sediment, so it is not possible to create a meandering channel. With mixed suspended load and bed load, however, meandering channels begin to build point bars on the side of the meanders and undercut their outer banks at the thalways, alternatively impinging on opposite banks. So, here if you see, once we are creating some bars, we are using these clays, finally the thalways is moving like that, and with more and more movement of the thalways, finally we are getting a meandering channels. So, meandering channels with time this part becomes cut off, this part become cut off. So, this channel will be like this. So, this part of the system becomes abandoned and this part of the system becomes abandoned with time. So, a total load is usually larger in this type of meandering channel. Channels are wider at sharp bends and along regular curving ridges. Such channels are quite unstable with acute cutoffs across this bank of these point bars, adding to neck cutoffs as a process of shifting. So, this meandering channel they shift frequently, and this forms point bars, and that is why the point bar migrates, and this point bar migration that we have already discussed, it creates a well porous and permeable sand below at the basal level, and it is capped by a clay sheet. So, they are the potential site for petroleum hydrocarbon exploration for geologists. Alluvial meanders are remarkably regular and their dimensions are proportional to the channel width. Here it has to be noticed how large the meander will be, what should be the curvatures of this meander, what should be this wavelength of this meanders, that all depends upon the channel width. So, channel width it says that the radius of curvature of meanders is usually between 2 and 3 times of this channel width. So, if this is the width of this channel, this radius of curvature here, the radius of curvature will be 2 to 3 times of that, and similarly the wavelength will be 10 to 14 times of this channel width. So, that means here is some mathematical relationship existing between this channel width and this radius of curvature and this wavelength of these meanders. Meandering increases the channel length between these 2 points and hence decreases the slope, and once the slope decreases, slope influences the velocity and sediment transporting capacity. So, meanders not only are affected by other variables of the stream flow, but also it is affect the same variables. So, that means I want to say this wavelength and this curvature, it is dependent upon this channel width, and once this curvature increases. So, here it decreases the slope. So, because its length is decreased and length is increased, the length is increased and the slope is decreased. So, this decreasing of slope it affects other parameters, other factors like sediment migrations and velocity of these channels, so that it influence the total fluvial system. So, here this image shows the geology or the stratigraphic relationship of this point bars. If you see here this part, it is suppose this channel is here, channel is moving in this way, this part is representing the sites of erosion and this site is representing the sites of deposition. So, erosion means here gradually erosion moves in this way and deposition moves in this way. So, that at this basal part this side you will get this coarse grained sands, and as this channel migrates in this way, it comes under this flood plain and finally it is kept by clays. Similarly, it is here it is mentioned in this stratigraphic cross sections. Here this is this basal section of this point bar, it is composed of these boulders, pebbles, cobbles, coarse grained sands, and here these channels, this total system is channel, this upper part of this channel it is cross bedded sand, and here this point bars it is ripple marks sand is there and fine sand is there, and finally, once this system is away from this flood plain, during flooding this type of silt and clay deposition is there. So, that in stratigraphically if you compare here, the lower part is composed of sand, porous and permeable materials, pebbles, boulders, and the upper part it is kept by clay and silt. So, that it is a good condition for petroleum hydrocarbon reservoir. So, in the fluvial environment, wherever the petroleum hydrocarbon exploration is going on, these are the potential sites and these point bars, for migrated point bars, the flood plane within the flood plain, they are the potential site for petroleum hydrocarbon explorations. Then the other side of this channel or other channel habit, it is the braided channel that we have discussed. One is straight channel, one is meandering channel, another is the braided channel. The braided channel, that means its name itself says it is braiding, that means branching. That means one channel is branched into different channels and different thulways, not channels. So, the channel will be same, but due to development of bars, the thulways will be multiple thulways and they join together, they diverge from each other and again they merge, but this channel remains one. This channel is bound by two separate banks and within that there are different bars, there are migration of the bars. So, these thulways migrate and thulways shifts from one place to another and it coincides and it diverges, finally it forms a braided channel systems. So, the total sediment load and the ratio of bed load to total load increases greater than 11%. So, and the channel width depth ratio increases and the slope increases, channel becomes unstable and changes from meandering to braided habit. Here those parameters that we are discussing here, like the grain size, the channel width, the slopes, they all are different from this range which is meant for this meandering channels. Here the total sediment load increases, but in meandering channels the total sediment load was very small. And the ratio of bed load to total load increases. Bed load to total load, that means bed load here is more as compared to total load, but in meandering channel mostly it is suspended load, clays. But here bed load increases, total load increases, channel width is to depth ratio increases. Channel will be more wider than compared to depth, but in meanderings and in a straight channel width depth ratio was less. So, here we are getting a wider channel with a more load, with a more bed load and the slope is also more. There in the meanderings and straight the slope was also very less. So, all these factors that defines a channel characteristics are more in terms of or in case of braided channel. So, channels become unstable and changes from meandering to braided habit. So, all these factors if you increase that, so channels becomes unstable and finally it will convert to a braided channel. So, if you see from this photograph, it is a braided channel. If you see number of channels and these are these bars, here these are the sand bars and this channel is multiforcation or bifurcation, multiforcation of channel and finally you are getting this is the channel width. So, channel is confined within that, that means it is channel is defined like that, but within that a single channel we are getting multiforcation of channels. So, within this is the bank, two banks they are bounding this channel and here there are hundreds of bars through which the thulwage is changing, thulwage is moving here and there. Point bars grow wide and are subject to frequent acute cutoff which isolate them from mid channel bars. Here if you see here these are the mid channel bars are there and finally this mid channels bar they are separating two sides or two different channels at different parts. Banks are also more erodible. Finally, the channel breaks into multiple thulways among gravels or sandbars which may migrate or becomes vegetated as islands. So, this is the mechanism which is responsible for formation of the braided channels. The intertwining threads of channel are then braided, diverging by avulsion and converging among the bars and islands. At bank full stage, a single wide channel may be seen at all and water level falls, the bars become progressively more exposed. So, this type of rivers or this type of channels during bank pull stage you cannot distinguish the bars, they are submerged. But once the water level decreases, so the bars are exposed, and finally you can find out how multiforked channels are there. So, the lower water channel floor is called bread plains. So, when there is a low water conditions and this water level at that position, that projected plains, that is called bread plains, which may be as wide as 20 kilometer in major bread channels. The bed load of breaded streams may be sand or gravel, and there are behavioral variations of rivers that are primarily carrying one or the other. So, these bread channels they carry gravels, coarse sands, and gradually once they move from distance, this becomes separated. The gravels and coarse sands they remain at the upper reaches, and this fine sands and clay particles they move further and forms the floodplains. Most gravel bed rivers also carry significant amount of sand, although sand bed channels may have only minor amounts of gravels. So, that means here gravel bedded rivers, gravel bedded channel may contain sufficient or significant amount of sand with that, but sand bed channels they rarely transport gravel. This depends upon the stream competency. So, gradually the stream competency decreases downstream. So, once the stream competency decreases, the size, the larger size becomes separated at the upper reaches, and finally gradually smaller and smaller size they are transported downstreams. Braided channels of bed load rivers tend to remain shallow at varying discharges, and they accommodate increased discharge by occupying additional channels. So, here this science is braided channel of bed load rivers tend to remain shallow. So, once there are shallow channels, that means the shearing action, shearing force between these grains and this water will increase. So, that they accommodate increased discharge by accompanying additional channels. So, that is why additional channels are developed, because to accommodate the discharge. Fluctuating discharge and net aggradation both favor development of braided channels. Fluctuating discharge is there, net aggradation is there, channel aggradation, that means the sedimentation, it is shallowing up. So, that is why it increases after the braided channels are developed. So, how channel respond to this grain size, that will be discussed here. A wide channel or a shallow channel optimized bed surface area as a device to move bed load efficiently by shear, that we are discussing minutes back. So, once the channel becomes shallow, it becomes more shearing force between these loads and this water. So, the interface between water and sediment, the shearing force is more. So, these sediments are transported in a shallower channel by shearing forces, by shearing between this water and this grain size. Bed load is carried near to this bottom of the stream. The velocity gradient increases rapidly upward in such a way that this relatively clearer, faster moving upper layer of water can erode banks made up of grain size similar to those already transported as bed load as they were widened, and finally this channel widens. So, now as last class we are talking about this velocity gradient in a channel. So, velocity is more near to the surface and at the middle of this channel. So, now we have a wide channel, and if we are taking this velocity gradient, these contours will be very close together, because it is a shallow channel and more width. So, contours are very closely spaced. So, that this water on the surface of this channel, that will move faster, and once this fast move water interacts with the bank, it will erode those bank material and will fall within this bank material will fall within the surface. So, that the banks becomes wider and wider and sediment load increases. Another factor is that sand and gravels are non-cohesive, and banks of coarse alluvium collapse readily to build bars on the flat shallow bed and create a braid pattern. Rivers that carry mostly mud, silt and clay as suspended load develop deeper and narrow channels. So, this is the reason behind it. So, because the sand which are mostly this composition or the constituents or the upper reaches or the braided channel, they are non-cohesive nature. So, that water can easily erode, and that is why the eroded material that becomes a supplement for the formation of these braid bars, bar development. However, this channels which is passing through fine silt and clay particles, due to their adhesive pores, they remain intact. So, that the channel will be more smooth here. So, that is why the rivers that carry mostly the mud, silt and clay as suspended load develop deeper and narrower channels, but which is carrying sand will be shallow and wider channels. So, a channel shape of this sort minimizes surface area of friction and therefore, provides for the maximum transport of suspended load, which is carried by fluid turbulence, not by bed shear. A deep narrow channel has steep banks which can be undercut, but this cohesive strength of this and smoothness of consolidated mud resist bank erosion. So, this is the that means once we are decreasing or increasing the grain size, that means we are changing the grain size, the channel behavior, bank behavior, the channel habits, they are changing. So, which is the channel which is transporting sand particles or coarser particles, they are of different kind, that different behavior as compared to these channels which are transporting silt and clay particles. So, here mostly it is suspended load, but in the finer the coarser particle, that will be transported through bed load. So, a deep and narrow channel has a steep bank which can be undercut, but the cohesive strength of this and the smoothness of this cohesive strength of these clays, they remain intact. So, this bank will be stable, but in terms of shallower channels which is carrying the sand with that, so this bank will be unstable. So, now the question arises, if there are two types of channels we are discussing, one is a shallow channel, wider channel carrying the sand with it at the prominent load, and another is a deeper channel and narrow channel which is carrying silt and clay as a suspended load, then which type of channel is more efficient? So, which river is the most efficient river? Either it is a channel which is narrow or is a channel which is more wide. So, here two types of channel, one is deep channel with less width and deep is more, one other is wider channel, depth is less. So, which channel is more efficient? So, to compare that, here we talk about this hydraulic radius of this channel. So, hydraulic radius that defines the efficiency of channel. So, what is this hydraulic radius? So, if the value of hydraulic radius r is large, so a small area of water in the cross section is affected by each meter of bed. So, frictional effect of this bed is limited and this efficiency is high. So, that means if you are reducing hydraulic radius or if you are increasing hydraulic radius, a small area of water in the cross section is affected by each meter of bed. So, this frictional effect of this bed is limited and this efficiency is high. So, if the value of R or hydraulic radius is small, the frictional effect of the large and the efficiency is low. So, here if you see, efficiency is a measure of ability of a river channel to move water and sediment. deep channels are generally more efficient than shallow channels. Larger channels are more efficient than smaller channels. So, here if you compare in this particular case, this is weighted perimeter 15 plus 1 plus 1. So, equal to 17 meter. So, in this case it is 5 plus 3 8 plus 3 11. So, here it is 11 meter, but cross sectional area both case is 15 into 1 equal to 15 meter, here 5 into 3 equal to 15 meter. So, hydraulic radius will be 15 by 17.88 and 15 by 11 in this case it is 1.36. So, that this river is more efficient, because here the hydraulic radius the efficiency is a measure of hydraulic radius. If the value of R is small, the frictional effect is large and the efficiency is low. So, here hydraulic radius is low and this efficiency is low, but here hydraulic radius is more, the efficiency is more. So, that means a narrow channel which much depth, it is more efficient to capacity, it is more efficient to transport water and sediment as compared to a shallow and a wider channel. So, a larger channel is more efficient as compared to a small channel. Similarly, a deeper channel is more efficient than a shallower channels. So, that means you can summarize here, this hydraulic radius is a measure of the efficiency. Some 1977 found that at a given discharge, the width to depth ratio of a river on the Great Plains is inversely proportional to the percentage of fine grained alluvium in this eroding bank, and therefore, also in the load. The relationship between the channel shape and sediment grain size is given by this equation here, F is equal to 255 m to the power minus 1.08, where F is the width depth ratio and m is the weighted mean percent of this silt and clay of this sediment. In many Great Plain rivers, the bed load may exceed half the total load. So, the value of m is low and inversely F is high. The braided habit of these rivers is partly an adjustment among interdependent variables of width, depth, sediment grain size, and partly the response to the external variables discharge and load. So, that means a channel habit, how this channel will be, how efficient a channel will be. So, that depends upon this how wider channel, or it is a narrow channel, it is a deeper channel, and what is its hydraulic radius, what is its weighted perimeter. This weighted perimeter, as we know here, this is the weighted perimeter. So, here weighted perimeter will be 15 plus 1 plus 1 17, here weighted perimeter will be 5 plus 3 plus 3, that means 11. So, weighted perimeter is here, then it is area of cross section area will be here, then hydraulic radius will be here area by weighted perimeter. So, more this hydraulic radius, more efficient the river is. So, the meandering habit of the rivers, especially those flow on the fine grained alluvium in humid region, can also be related to width depth ratio of this channel and sediment grain size. By these interrelated adjustments, more of this energy of the stream is extended against the bank and less against the deep bottom. The sinuosity of thallways and channel increases and meanders are formed. So, these are the mechanisms how we can create a meandering river, a river straight braided river or a straight river by changing these variables of this grain size, slope, this width, depth, all these types of parameters that we can change accordingly, and we can create different types of channels. Similarly, in the natural environments also this type of model can be applied to create meandering channels, to create straight channels. So, this is very much useful for water recharge purpose. For example, we are creating a meandering channel in a particular area. So, that means more time the water will interact with the surroundings, so that more recharge will be there. Or if you are straightening, that means within a less time we are discharging high amount of water. So, that means there will be less chance of recharge of this area. So, artificial recharge, this can be used, this idea can be used for artificial recharge zone, creating artificial recharge zone and diverting channels in different habits within that systems. So, I think we should stop here and we will meet in the next class. Thank you.